Good morning, everybody. We're going to be reviewing for the culminating activity today. Remember, the culminating activity for seniors is a 15-question exam on Google Classroom. So for seniors, you're going to be taking it either Wednesday, Thursday, or Friday, depending on your class period. Today, we're going to be reviewing the first 7 questions. It is very, very important that you review because you do need to score at least minimally proficient on the culminating activity. Otherwise, you could possibly get an incomplete for the course and have to complete it either during the summer or in the fall. So please actually try the review problems and do your best. So what we're going to do for each problem is I am going to show you a practice problem and then you're going to try a practice problem. So you do need a sheet of paper so that you can try each practice problem. If it's helpful for you to have a calculator, you can have that as well. All right, let's get started. So number 1 is to multiply 2 complex numbers. So we're trying to multiply 3 minus 5i times negative 6 plus 2i. We're going to distribute or FOIL this. You could also use box method. But the one thing we're going to have to remember here to simplify is that I squared is equal to negative 1. Let's go ahead and set this up with box method. So I'm multiplying 3 minus 5i times negative 6 plus 2i. So when I multiply in each box, this box would give me negative 18. This box would give me positive 30i, since I'm multiplying a negative times a negative. This box is 6i, and then this box is negative 10i squared, because we're multiplying 2i times negative 5i. So I can combine the numbers in the diagonal. So when I combine the numbers in the diagonal, so far I'd have negative 18 plus 36i minus 10i squared. But we're never going to leave an I squared. We need to simplify this. I squared is equal to negative 1. So I'm going to replace this I squared with negative 1. And it's multiplied. So negative 10 times I squared would be negative 10 times negative 1. And that would give me a positive 10. Now this positive 10 can be combined with the negative 18. So negative 18 plus 10 would be negative 8. And then we still have the 36i. So negative 8 plus 36i. That's as simplified as we can get it because I can't combine the regular number with the imaginary number. So that's what our answer would look like on a multiplying problem. All right, now you guys are going to try this practice problem. So same thing, you're trying to multiply 8 minus 3i times 3 plus 2i. Go ahead and pause the video and work out the problem, and then you can check your answer. All right, hopefully you checked your answer, or hopefully you tried the problem, and the correct answer is D. All right, number 2, we're trying to solve this equation by factoring. So the equation we have here is x squared minus 9x plus 36. Hopefully we recognize that this is a quadratic equation. So on a quadratic equation, if we're going to solve by factoring first, we have to get one side equal to 0. So to do that, I'm going to subtract 36 from both sides. So then we have x squared minus 9x minus 36 equals 0. Now I should be able to factor this left side here. I'm looking for numbers that multiply to be negative 36 and add up to negative 9. So the numbers I can think of are 12 and 3. Since the leading coefficient is just 1, I know my factors are just, my first terms in my two binomials are just x and x. And the numbers that multiply to be negative 36 and add up to negative 9, I would need a negative 12 and a positive 3. So my factors would be x minus 12 and x plus 3, and that's still equal to 0. Don't forget to actually solve. So now you have to set each factor equal to 0. So x minus 12 equals 0 and x plus 3 equals 0, and then solve each one. So to solve this equation, I'm going to add 12. So we get x equals 12. On this equation, I'm going to subtract 3. So we're going to get x equals negative 3. So those are my two answers, 12 and negative 3. All right, time for you to try a practice problem. So you're trying to solve a squared minus 10a plus 21 equals 0. So again, pause the video here, try the practice problem, and then check your answer when you're done. All right, the correct answer on this one, number 2, the correct answer is B. All right, number 3, we're trying to solve using the quadratic formula because we're not going to be able to factor this one. So we do need to know the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is in the correct form. We need our equations in the form ax squared plus bx plus c equals 0. So make sure it's equal to 0. This one's already equal to 0. That means the a is 2, the b is negative 3, and the c is 5. All right, let's plug those all in to the quadratic equation here. We're only plugging in the numbers, not any variables. So x equals negative b, that'd be negative negative 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times 2 times 5, 4ac, all over 2 times 2. All right, now let's simplify. I'm going to simplify what's under the radical first. This would be positive 9 minus 4 times 2 times 5 is 40. And 9 minus 40 is negative 31. Now, when we have a negative under a radical, we have to remember that that's not a real number, that's an imaginary. So I need to write this with an imaginary. So a negative under the radical brings an I on the outside, so this would be I square root of 31. In this case, square root of 31 doesn't simplify, so I'm just going to leave it like this. All right, let's simplify now. So x equals, right here, instead of writing negative negative 3, I would just write positive 3 plus or minus the square root. This whole thing here is simplified to I square root of 31 over 4. Now, in some cases, we can divide both terms by 4, not in this case. So we would just leave our answer like this. On a multiple choice question, it's going to be written as two solutions like this: 3 plus I square root of 31 over 4, and 3 minus I square root of 31 over 4. So instead of writing the plus or minus, it'll probably be written as two separate answers. All right, so now your turn to try one. So here's the practice problem. Solve x squared plus x plus 4 equals 0. So pause the video and try the problem, and then check when you're done. Okay, let's check our answer for number 3. The answer for number 3 is C. All right, number 4. Now we're doing some work with functions. So number 4 says find f of b plus 2 if f of x equals 3x squared plus 2x plus 4. So we're evaluating a function here. What this means is that we are plugging in the b plus 2, that's the input. We're plugging that in anywhere there's an x. So the b plus 2 is the input. So I'm plugging it into my function. Both places there's an x. So when I do that, it's going to look like this. F of b plus 2 equals. So right here, I still have the 3 in front. Instead of x, I'm plugging in b plus 2 squared. And then plus 2 right here again. Instead of x, I'm plugging in b plus 2 and then plus 4. So that's what it looks like when I plug everything in, but now we have to simplify as well. So right here, to simplify 3 times b plus 2 squared, remember we have to do exponents first. So I have to do b plus 2 squared first. That means b plus 2 times b plus 2. So to multiply that out, you have to use either distributive property or box method. I'm using box method. This would be b squared plus 2b plus 2b plus 4. And remember, we can combine those diagonals since they're both positive 2b. That would give us b squared plus 4b plus 4. Now, don't forget, we still have this 3 in front. So now that we did the exponents, now we can multiply by the 3. So I have to distribute that 3. So that would be 3b squared plus 12b plus 12. Then we still have the rest of our function here. So right here, I have to distribute the 2. So plus 2b plus 4. And then we still have this plus 4. After I got rid of all the parentheses, now I just have to combine like terms. So we have 3b squared. Then I can combine the 12b and the 2b, so plus 14b. And then I can combine the numbers. 12 plus 4 plus 4 is 20. So our final answer, f of b plus 2 equals b squared plus 14b plus 20. Since our input was a variable expression, our output still has variables in it. All right, your turn to try one. Find f of k minus 3 if f of x equals 2x squared plus 4x minus 6. Pause the video here and try the problem, and check your answer when you are done. All right, the answer to number 4 is 2k squared minus 8k. All right, next problem, number 5. Find the intervals of increase and decrease. So on our function here, we tell if a function is increasing or decreasing by whether it's going up or down as we go from left to right. So I'm starting over here. As I go from left to right, the first part of the function is increasing till it gets to that point here. Then this section is decreasing till it gets to this point. Then the function is increasing again till it gets to that point, decreasing in this little section here, and then increasing again. Now, hopefully we remember when we write our intervals of increase and decreasing, we are only using the x values of these points. So this x value right here is -8, where the graph changes. This x value here is -2.5. This x value here is 2.2. And then this x value here is 5. And then the ends of our number lines are -infinity and infinity. Remember, we're only using x values, so I'm only looking at the x-axis. If I just draw the x-axis, so I have -infinity and infinity, my x values that I'm looking at are -8, -2.5, 2.2 are my 3 points here, my 3 x values. So my intervals, remember we split this into intervals. We have -infinity to -8 is my first section or interval. -8 to -2.5. The next section is -2.5 to 2.2. And then the last section is 2.2 to infinity. And we already decided whether these were increasing or decreasing. So we said the first interval was increasing, then the graph was decreasing, then in this section, the graph was increasing again, decreasing. Oops, I missed one. I missed the 5 right here. So, whoops, we got another interval. So, this interval, sorry, I missed an interval. I missed this point here. 2.2 to 5. And then our last interval would be 5 to infinity. All right, so we said this little section here from from 2.2 to 5 is decreasing. And then the last section from 5 to infinity is increasing. All right, so another way we can write this is we can say the graph is increasing on all of these intervals. These are the increasing intervals. -infinity to -8, negative 2.5 to 2.2, and 5 to infinity, which means the function is decreasing on the other intervals. It's decreasing on negative 8 to negative 2.5, and then decreasing from 2.2 to 5. So notice these are not coordinate points, they're intervals using the x-axis here. So the increasing intervals correspond to these parts on our number line, and the decreasing intervals correspond to those parts on our number line. All right, your turn to try one. So here's a practice problem. Find the intervals of increase and decrease on this function here. Remember, you're only using x values. So pause the video here and try the problem. All right, let's check our answer. The answer for this one, the graph is increasing on the interval from negative 1 to 0 and then 1 to infinity. So that's increasing. And then the graph is decreasing on negative infinity to negative 1 and 0 to 1. So the graph is decreasing in those sections of the graph. All right, number 6, talking about some transformations. The graph of a function f of x is given below. What is the equation of the graph? All right, so the thing we have to know here is we got to recognize the parent function. We can kind of tell the parent function by looking at the choices. The parent function is going to be f of x equals square root of x. And usually the graph for that starts at 0, 0 and points to the right, like this. So I got to see what transformations are taking place and then match it up with the function. So a couple of things. First of all, this graph, my transformed graph, is reflected. It's pointing towards the left instead. So one of the transformation that's taking place here is that it was reflected over the y-axis, which actually changes all the x values to negative. It flips left to right, so it's affecting the x values. So that means there's going to be a negative in front of the x. So if I look at my choices, it could be this one, or this one. The negative is with the x. I know it's not choice B or C because on those ones, the negative is on the outside. So that's affecting the outputs and flipping it up and down. Okay, so the other transformation that's taking place is that this is shifted after it's reflected. It is shifted to the right too. Now remember, when something is shifted to the left or the right, we're adding a number with the x. So the number needs to be added with the x, so either here or here. We know now it's not a because the +2 here is on the outside, so it's not with the x. That would be affecting the outputs instead. Okay, but one thing to remember, if something is shifted to the right, it's actually doing the opposite. So this would actually be a subtract 2 with the x. So the one with the subtract 2 with the x is choice T. So we had to recognize the parent function and then look for the transformations that are taking place. All right, your turn to try one. This one, we're given a parent function of x squared, and here's the graph. So figure out what transformations are taking place and match it with the graph. Pause the video here, and once you have your answer, then check it. All right, the correct answer on this one is B, because the graph has been shifted left 2 and down 1. All right, last problem for the day. We're going to graph f of x equals x plus 1 squared minus 4 using transformations. So remember, if we are graphing using transformations, first we have to identify the parent function and points on the parent function. In this case, our parent function is, I see the squared here, so the parent function is x squared. So anytime we're graphing a parent function, we need 3 points to start with. And for our x values, we typically use -1, 0, and 1. And then to find my original points, we just plug them into the parent function here. So I'm plugging them into here. If I plug in a negative 1 squared is just 1. If I plug in a 0 for x, 0 squared is 0. And if I plug in a 1, 1 squared is 1. So these are the starting points. Now there are two transformations here. This plus 1 with the x affects the x value. So remember though, with the x we do the opposite. So we're actually going to subtract 1 from x. I'm subtracting 1 from all the x values. So my new x values would be -2, -1, and 0. So far, I haven't changed my y values, so my y values are still 0, 1, 0, and 1. Okay, now this -4 on the outside affects the outputs. So that's going to affect the y values. So for that one, we're going to subtract 4 from y. Things that affect the y, we do the operation that we see. So I'm subtracting 4 from all the y's. So my x values are not changing in this step, -2, -1, 0. My y values are -3, -4, -3. Okay, once we have our 3 points, those are the points we want to plot. And then we also need to know the shape of our parent function. So I'm plotting these points. So -2, -3, -1, -4, and 0, negative. Now, hopefully we recognize the parent function is the parabola shape. So once I have my 3 transformed points, I draw in my parabola. So there's my transformed graph. All right, last practice problem for you. So you're trying to graph f of x equals x minus 4 squared minus 5 using transformations. So pause the video here and try the problem, and then check the answer when you're done. All right, on this one, here's the points on the parent function. So the parent function again is x squared and has the points -1, 1, 0, 0, and 1, 1. I graphed it in black on the graph here. These ones are the transformed functions: 3, -4, 4, -5, and 5, -4, because we would be adding 4 to the x values and subtracting 5 from the y values. And then here in blue is our transformed function. All right, that's it for the day. Now you should do the Google form. The Google form has 7 more practice questions that look similar to these. So try those and make sure that you check your answers. That way you know how you might do when you actually take the culminating assessment either on Wednesday, Thursday, or Friday. All right, everyone. See you tomorrow.